Hello students, in this video we are going to learn about SRAM read and write circuits. In previous video we saw about the leakage current of your SRAM device, and in this video we are going to learn about the read and write circuits. So in previous video I said that we learned about the leakage current, and here we also saw in previous videos about the operation of your SRAM. We saw about the read as well as the write circuitry and the assumptions that we saw. We had a pre-charge circuit that was charging or pre-charging my bit and bit bar line to be equal to VDD. And at the same time I had a 6 transistor SRAM that is being connected to the pre-charge circuit. So the pre-charge circuit is connected to your SRAM design. And now read circuit is a new concept. What is that read circuit? I'm going to sense the value or the voltage which is present in your bit and bit bar line, because I said that bit and bit bar line are going to act as the output in your read circuitry. So in that cases I have to sense what value is present in my bit and bit bar line by using a sense amplifier. So what is the down part of the circuit? P5, P6, P7, P8, N5, N6 and N7 or nothing but that is a sense amplifier. So here I am having two pass transistor, I mean PMOS FETs, which is P5 and P6, and again I am having there is a two cross coupled inverters. So these two cross coupled inverters, again there is an N MOSFET that is given with the input of read enable. Right, this is a read circuitry. Again I will say you the glimpse of that SRAM operation. Thing is, I had a pre-charge circuitry. Again, I had a 6 transistor SRAM model. Now I am adding a new circuitry that is going to perform the read operation. So far, we sought to stabilize the nodes N1 and N4 by using the stability criteria. Now we are going to perform the actual read operation. So this is a circuit of your read operation. Now see, I have given the same circuitry over here so that you can understand the operation of your read. So now see, when my psi is equal to 0, if I am giving psi is equal to 0, what is happening? P3 and P4 will be turned on. When my P3 and P4 is turned on, my bit and bit bar line will be pre-charged to VDD. Now I am enabling my read signal. So when my read enabled is equal to 0, when I give my enable signal to be equal to 0, P5 and P6 will be turned on. When my P5 and P6 are turned on, what is happening? The value which is present in my bit bar is moving to the node voltage X, and the voltage which is present in bit bar will be moved on to Y. And at the same time my N7, which is also in off condition, it is also in off condition, which means there is no path for my output to discharge to ground. Now what is happening? Bit voltage is stored in the point X and the bit bar voltage is stored in the node Y. Now previously what was passing in bit and bit bar? It is VDD. Now what I'm going to do is I'm going to make my read enable signal to be equal to 1. When I make my read enable signal to be equal to 1, what is happening? P5 and P6 are turned off, right? P5 and P6 are turned off because one is going to a PMOS, will turn off the PMOS FET. So this P5 and P6 are turned off. When P5 and P6 are turned off, what is happening? It is cut off from my bit and bit bar line. But what it has done previously, my P5 and P6 has already transferred the bit and bit bar voltage to the node X and Y. Now assume for the voltages from 0 to 0.9, I am storing a 0 according to digital, and from 0.9 voltage to 1.8, I am storing the voltages on digital. I can say it is having the value as 1. Now see, the X and Y are now my circuit. Only the bottom part is going to perform my read operation because I made my read enable to be equal to 1. So this circuit is been completely cut off. Now see, when X is given to X is acting as an input to P8 and N6. It's not N10. When X is going to act as an input to P8 and N6, and Y is going to act as an input to P7 and N5, right? So this inverter is getting the input from Y, and this inverter is getting the input from X, right? Suppose my X is 1.6 volt. Okay, bit voltage was already there and that has been transferred. Consider my bit line voltage is 1.6 and my bit bar line voltage is 1.8. I'm assuming, right? So which device will have the larger drain current? X is having and value of 1.6, that is acting as an input for P8 and N6. So this inverter is getting 1.6, whereas this inverter is getting 1.8. Which will discharge fast? The one which is having the higher voltage will discharge fast, which means the drain current of Y will be discharging faster than your IDX, right? So X will be discharged fast than your Y, because your X input is going to this second inverter and Y is going as an input to the first inverter. So Y is getting a higher voltage, which is 1.8. The one which is getting higher voltage will be discharging fast. So the node X is going to discharge, and it is going to discharge towards 0. So what was thing which is written? We were performing a read operation. The node A, we said that it is storing the old value of 0. Now by using the read circuitry, I mentioned or I observed my X value is equal to 0. By enabling my read circuitry, I transferred my bit and bit bar voltages. Once I transferred, that particular circuitry is completely been cut off from the main circuitry, and then my X and XY value will be observed, and that is given as an input to two inverters, and which one is getting the higher voltage will be discharged first, and thereby my X is discharged to 0. So when I keep a probe over this point, I can observe that it is 0. So when I find that it is 0, which means that value which is being read is nothing but 0 in your memory cell. If suppose I am getting a value as 1, which means my data that has been already written is nothing but 1. So this is your read circuitry. Now I'm going to the write operation, which is write circuitry. In the same way like your read operation, I'm having a separate circuit for write. So here, which is I'm having a write enable pin that is given to N5 and N6. And one terminal of your N5 and N6 will be the bit and bit bar, same as in the case of your read circuitry. And again, two more transistors, which is N7 and N8, that has been connected with an inverter, and the input of an inverter is given to a data value, because I'm going to write. So I have to write some data. So whenever my write enable pin is equal to 1, what is happening? N5 and N6 will be turned on. And I'm going to write a data which is equal to 0. So when I write 0 here, what is going to happen? The 0 is going to N5, N7, and N7 is going to turn off. So this 0 is again going at the output of the inverter. That will become as 1. So 1 to an N8, which is N MOSFET, will turn on the device. Now N5 and N6 are already on, right? Because my write enable is there. So N5 and N6 are on. So bit value will be passed over here, and in this node bit bar will be there. Now my N7 is off. So my bit voltage will still remain the same, whereas your N8 is on. So what is happening? This N8 is going to pull down the value of bit bar towards ground. So the N8 is going to pull down your bit bar is equal to 0. So now my bit is equal to VDD, because there is no path for discharging, whereas my bit bar became equal to 0, right? When it happened, when I am going to write my data value as 0, my bit is storing the value of VDD, and my bit bar became equal to 0. That is what we in previous video we saw the operation. There we assumed bit is equal to VDD and bit bar is equal to 0. I am explaining you how that bit bar became 0 and bit became VDD because I'm going to write a data of 0. The 0 is being written, N7 is turned off and N8 is turned on. Because of that, my bit bar is being discharged to ground. Now see the circuitry What is it? On top there is a pre-charge circuitry. Again there is a static SRAM because two cross-coupled inverter with two access transistor. On the down part I am having the right circuitry. What is the right circuitry? What we have seen here is being connected here. So the bit and bit bar line is connected to the right circuitry. When my write enabled is equal to 1, my N5 and N6 are turned on. The data that I'm going to write is 0. So when 0 is being written, N7 is turned off and N8 is turned on. That is going to make my VDD in bit line, and whereas my bit bar will become equal to 0. So now my bit bar is equal to 0. Right now my bit bar is equal to 0. Coming to this point, see now my bit bar is equal to 0. Now which transistor we saw the condition for write stability. In write stability, what was the condition? Whether your P MOSFET is stronger or your N MOSFET or access transistor is stronger. When there is a race between P2 and N4, which won the race? N4 won the race, which means the N MOSFET, a pass transistor is having higher W by L ratio. So what is happening? My bit bar line is 0. Now there is a node B. This pass transistor is turning on. Thereby the voltage which is present on the bit bar line will be directly written into B irrespective of P2. So now bit B is equal to 0. So when B is equal to 0, what will happen? My P1 will turn on. P1 is on. When P1 is on, what is going to happen? The node A is going to store the value of 1. That is what, right? When my word line is on, this will be going to write the data. So in the same way, what we did, first we are going to perform a write operation. For performing a write operation, what we did is we enabled that pin. N5 and N6 became on, and we are passing the data that we are going to. Based on the data, your N7 and N8 will turn on and off. So my bit bar now it became 0 and bit has become equal to VDD. Now when my bit bar is equal to VDD, we know the write stability criteria that pass transistor will be having stronger width than your P MOSFET. So what is happening? My B value is being easily written with the value of 0 as your word line is activated. So when my word line is activated, this transistor is turned on. So the voltage in your bit bar line will be transferred towards the B. So B is storing a value of 0. When B is equal to 0, I can easily store the value of A as 1. So this is a simple read and write operation. So whenever a question comes, you have to just draw the complete diagram where you have a pre-charge circuitry, SRAM, and the read circuit, and explain the operation. In the write operation, you just draw the pre-charge circuitry, SRAM, and the write circuitry. So this is all about the read and write circuitry. So in next video, we shall see about the layout of SRAM. Thank you.